Hi, welcome back to the shop. This is part 3 on the small single-cylinder steam engine. In the past episodes we machined the base, the A-frame and the bearing blocks. I made off-camera the brass bushings that go in these bearing blocks because there was not much interesting about them. They were just turned from cast bronze rod material and made to fit the bearing blocks. I also started to machine the cylinder head, which was also just turning. So far it's only turning. I still need to drill the 8-hole pattern for the bolts. But in this episode we will start to machine the cylinder, which is a pretty complicated piece. It's the cylinder and the valve box is one piece, and there is really nothing to hold on so far. The outer diameters here are not super round, and also these surfaces are not super parallel, and I was not sure how to hold this. Also this down here is of course not flat because of shrinkage on the casting process, and also these sides have signs of shrinkage, so you can't hold it that way. And I was really not sure if I started on the lathe or on the milling machine, but I decided to go for the milling machine. We will machine one reference surface, and then we will proceed over to the lathe and line bore the cylinder. Yeah, this is going to be fun. What we're going to use as a reference on this part is the bore. The bore is the cylinder is cast with a core. In the first episode you saw me picking out the sand core with a screwdriver. And the bore is actually pretty precise. It's supposed to be about 26 millimeters, and as you can see, it's not super round, but it's close enough. And the bore is where everything references off later. And I had a piece of 25 millimeter. This is shafting material, hardened and ground shafting material, and this fits pretty precise into the cylinder, and there is not much wiggle, and that's a good starting point for the machining. Now we can rest this, the precision ground stock here on something, hold the cylinder and machine at least one surface flat. So after that we can flip it around on that machine surface and true up the bore and machine then the flanges. So okay, we're over at the milling machine, and I have the cylinder here and my piece of 25 millimeter precision ground rod, and now we can put this into the vise. There are two parallels up here on the vise jaws, and I can simply drop my part between the jaws of the vise and let the steel rod rest on these two parallels. Now we tighten the vise finger tight, so we can still adjust it slightly. And now my specialized square comes in. These are two machinist squares C-clamped together, carefully of course. but also these are no precision squares. And with the second square over the workpiece, I can kinda align it so it's yeah, kinda square to the table. And as you can see, the gap between the part and the upper square is pretty much constant, so the surface is not too much off in that direction. It's pretty wonky in that direction, as you can see when I start here, big gap, and when we pull it to the front, yeah, now the square rests on the workpiece. But that doesn't matter for this purpose, as we want to machine this down now. Okay, this is again the setup from a different view. I added some cardboard again, as this is a raw casting and there are irregularities as you saw before, and the cardboard really does a good job of increasing the holding power by filling those voids. And I have my medium-sized fly cutter up here in the spindle. I have the spindle set to 580, and we're taking a first pass on this surface. So you just saw me run the fly cutter over the surface, but now we need to check the distance of this surface against the rod. I calculated the distance from the surface of the valve box against the edge of the rod, and that distance is 24.5 millimeters, so I can measure this with my depth mics. And I just drop it on here. And of course, as this is round, I have to find the high spot. Let's take a measurement here. 24.63 seems to be the high spot right here. So that means that we have 0.16 millimeters to go. Okay, I took another finishing pass, and the surface finish this time is very, very good. I used a little bit of cutting oil. And let's take another measurement. Let's do this so you can see the actual dial of the and as you can see, we hit right away the high spot, and we hit our 24.5 millimeters, pretty good, about hundredths of a millimeter off. And this measurement is not super critical, as we can still correct the location of the bore when we do the actual boring. Right now we're referencing off the cast bore. So now we're over at the lathe and we're setting up for line boring. I already removed the top slide, and I bolted on my angle plate. That's also aligned in that direction with the travel of the machine. I have a Morse taper 2 ball nose that's centered in the spindle, and I have a 26mm plug in the tailstock, which I had accidentally laying around. I think that came with my rotary table to align the 3-charge up, but I never use it. Now I can just crank the table out of the way, crank the angle plate a bit back, and rest the part in pieces. Now rest it between centers and bring in the angle plate by cranking the cross feed in. And now the part is it's semi-aligned. It's aligned in that direction for tilt and for rotation and all that. And now we can bolt it down, and then we have to use the edge finder, touch off on the surface of the angle plate, which is also the top surface of the valve box, which is our reference surface right now. And then we have to move in 37 point something. I have to check that measurement, but that's the general idea. Now we need to get some clamps and hold this in place. Okay, I clamped it down, one clamp with some thin cardboard between. Should be enough. We are not hogging away material, we are just line boring. I think that's suitable. I have the edge finder in the 3-charge chuck, and I set up my dial indicator against the faceplate as a makeshift DRO. And of course, because of glare, you can't see the display. Let's see if I can. Okay, this is a little bit better. Now you can kind of see what's happening on the display. And I will adjust the dial indicator slightly. And now we will use the edge finder to touch off on the angle plate, which is the surface of the valve box. And there it kicked. Now we can zero our DRO. There we go, 0, and repeat it. And there we go. You just saw me covering up the display by hand, so you believe me that I did the touch off by looking at the edge finder, not on the actual dial. And as you can see, it shows 0.001, and that's the repeatability of this edge finders. Those are incredibly accurate if you work if you pay attention. Then they are just accurate, that not some. And now we need to move the table in that direction, so our spindle is directly in line with the spindle bore, with the cylinder bore. Of course, the travel of the dial indicator is only 10 mm or something like that, but that's again where our gauge blocks come in handy. We have to move in 37 mm from the valve box, but we already are 5 mm in because that's the radius of the edge finder. So here I have a 32 mm gauge block stack up. That's 37 minus the radius of the edge finder. And now I will crank the table over, or the cross feed, just to clear the edge finder. Then I will drop in. I will make sure there is no dirt on the angle plate. I will drop in my gauge block, gauge block stack up, and I'll crank the cross slide back until this reads 0. There we go. Now we are with the center of the spindle 37 millimeters away from the from the angle plate. Now we can lock the cross feed or the cross slide, remove the dial indicator, and set up a boring bar. Okay, I set up my between centers boring bar, which I in fact just chucked up in the 3-jar chuck on this side. And I took a first skim pass in the cylinder, and it went very well. I took a nice clean cut all around, cleaned up almost the whole bore, and the tool I'm using is cutting very nicely. But in fact, it's hard to mess up surface finish on aluminum, cast aluminum. It produces most of the time a pretty decent finish. Sometimes it's a bit scummy, but most of the time it's fine. I adjusted the tool for another 0.4 millimeters cut, and we're going to run this cut now. And as a side note, I set up my power feed of the lathe. Yes, I went down to the powertrain, I changed the change gears, which is a real pain in the neck to do on this machine, and I have an idea how to improve that, but that will be a separate video, or I think even a video series of a build to make a improved change gear banjo that is not a pain to use. Yeah, and we will run the feed at 0.1 millimeter travel per revolution and see how it goes. Okay, back here you can see the drivetrain that I think most of the 9x20 lathes have, and you have this banjo which can be swiveled in and out by loosening this screw, and then you can engage and disengage this upper gear to the main spindle, and this works pretty good. It's a bit rough, but it works. What's a real pain is to adjust the distance between those axles when you change the actual gears. The gear changing also is not too bad, but the adjusting for those pins is just awful. But I have an idea how to fix this and make it very usable. But for now we just want to engage the feed. And of course you want the whole gear train to have a bit of play, so it doesn't bind up on you. Okay, let's go. Give it some RPM and let it feed in. And before that I will add some cutting oil to the bore, just to make it a bit more easy cutting. And what works well on aluminum is of course the good old, yeah, that stuff. I'm using it because it's in a nice spray bottle, and I can just squeeze some in there. Reaching in with the acid brush is a bit hard. Okay, engage the feed. There we go. There we go. Disengage the feed and turn off the spindle, and we did a nice cut there. Runs smoothly, no sound that make you worry about something, just plain old cutting noise. Okay, in that case we can easily measure the bore with the 2-point internal mic, as we can reach in the bore from both sides and we can check if it's parallel over the whole length by measuring it on both sides. and but as with all measuring devices, it's just getting a feel for the tool. And the internal mic, the 2-point internal mics are very prone to get stuck. We are 27.49, and on the other side we have 27.49, and that was to expect, as I know that this lathe turns very parallel. So now we can adjust the cutter. We have to open up the bore to 30 millimeters, and right now we are at 27.49. And as I mentioned somewhere else, I always like to write down my numbers. Nothing is worse trying to remember a number and then adjusting your cut and overshooting as you recall the number the wrong way from your brain. When you write it down, you have something to reference off. Okay, I did some cuts off camera, and now we're at 29.5, and we need to increase the size of the hole by another 0.5 millimeters, and I will show you how I adjust the cutter in this boring bar. Just short to explain, the boring bar is just a piece of cold rolled steel. It's cross drilled to take a small carbide turning tool with a 3 millimeter diameter. It's a reground shank of a carbide end mill, and there is a screw 90 degrees to it, a set screw to clamp it in position, and behind the cutting tool is another set screw to advance the cutter. When I turn the screw, the tool will be pushed out, and that's what we're using to fine adjust the diameter. And I have my digital indicator here with a big flat tip. We will rest the cutter against this tip. We will look for the high spot. That's here, about pretty much here, and we zero the dial indicator and don't touch it anymore. The 1000 indicators are very sensible. We will use one Allen wrench to loosen the set screw up here, and the second one back here to advance the cutter. We want the hole to be 0.5 millimeters bigger, so the cutter has to advance 0.25. 0.1, 0.2, 0.25. There we go. Now we can lock it. Remove our dial indicator. Remove our dial indicator and snug it up, and we're good to go. And there we go. Some WD-40 and engage the feet. There we go, that should be our last cut. Okay, I withdraw the cylinder from the boring bar over here so I can take a measurement, and I have my internal mic here and we will measure it. And as you can see, we are almost dead nuts on 30.00. Let's check it on the other side. Make sure everything's clean. And there we have it to 30.00. I will tear down the setup, bring the lathe back in normal operation by putting the top slide back on, and we will proceed with the cylinder. So now we have our cylinder bored out to the desired diameter, and we want to machine the flanges on the ends, and we could chuck it on the inside with the jaws like this and turn the other side and so on and so on, but I don't want to chuck on the freshly bored surface. Instead, I found a piece of 30mm drill rod in my scrap box, and I chucked it up in this reach-jaw and checked it for runout, and it's running about 0.02 of a millimeter, and that's perfectly fine. And notice that I have a new dial test indicator without a broken glass. The MAR dial indicators were on sale with my with the tool supplier I have, and I just ordered a new one. And the nice thing on a new measuring tool is they come even with a proper test report, not like some other tools. What we can do now is we can push the cylinder over this piece of drill rod, and this is very precisely aligned. Of course, we can't machine as there is no direct connection between the drill rod and the cylinder. But we can use something that's called a chemical press fit, or otherwise known as Loctite. And I'm not going to use my usual bushing retaining Loctite, as it's horrible to get off again. For this purpose I'm using a medium strength screw retainer, and that will hold the cylinder good enough on this piece of drill rod to machine the casting out here. And we will just put some of it on here, and get some under the cylinder and some in front here too. Just to give it a good bond, and we push it over the drill rod, make sure it's sitting in a good position, and now we wait until and it's already setting, until the Loctite is set. This will take about, in a few minutes it will be strong enough to handle. In fact, it's already bonding up pretty good. I will not do any machining to this part today. I will wait until tomorrow until the Loctite has fully set, and I can do the machining on this side. And we heat it up slightly so the Loctite releases. Then we will press out the slug, the drill rod in there. Let's see. Yeah, now it's finger tight. Then we will press out the slug, turn it around, then we can clamp it on a faceplate, for example, when we have one face machined, and machine the other flange. But so far this is going to work. That's for sure.